Hello, welcome back. For today, we're going to be doing trigonometric ratio of special angles. Now, there are 180 degrees. Okay, sorry, there are 360 degrees in a complete circle. And I believe that's also it for angles. Now, we have angles that are regarded as special angles, and they are angle 45 degrees, angle 60 degrees, angle 30 degrees. So these three angles are regarded as special angles. Now, trigonometric ratio of special angles, I'm going to be starting with that of 45 degrees. Now, so the trigonometric ratio, I believe you already know, are the sine, cosine, tangent, cosecant, and the rest of it. But I'm going to be focusing on sine, cosine, and tangent. So to prove the trigonometric ratio of special angle 45 degrees, I'm going to be making use of an isosceles right angle. An isosceles right angle triangle. As you already know, a right angle triangle is a triangle that has one of the angles to be a right angle. So now let's assume that this here is a right angle triangle. And this is my 90 degrees. And you know, an isosceles triangle is a triangle that has the base angles to be equal. So now if this here is a right angle triangle, which is 90 degrees, and I have 45 degrees here and 45 degrees here, you can see that these two angles here are equal, which means that these two sides are equal. So this here is an isosceles right angle triangle. So now let me label this right angle triangle A, B, C. This is my small a, small b, and small c. So now for this right angle triangle, since it is an isosceles triangle, it means that whatever we have here is also what we have here. So the two sides are going to be, since they are equal, their measurement should also be the same. So let me assume that I have 1 kilometer here and 1 kilometer here. Sorry, 1 centimeter and 1 centimeter here. Using Pythagoras theorem, which states that this my hypotenuse for this particular triangle is a, so I'm going to be saying a squared is equal to b squared plus c squared, and my b is 1, my c as well is 1, so my a squared is going to be 1 squared plus 1 squared. So my a squared is going to be 1 plus 1, which is equal to 2. So I find the square root of this and the square root of this, and I'm having that my a is equal to root 2. So it means that a here is going to be root 2. So my hypotenuse for this particular isosceles right angle triangle is root 2. Now, since the angles here are 45 degrees, I'm going to be using those trigonometric ratios that we know to find the, this is 45 degrees. So I'm going to be finding those trigonometric ratios for this particular. So the trigonometric ratios that we have are tan, sine, and cos. So these are the ones that I'm going to be focusing on. And I gave us an abbreviation in one of our previous videos, so I'm having SOCAR. So my tangent is opposite over adjacent, my sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So now let's assume that in this right angle triangle that this is the angle that I want to make use of. Let me call it my angle theta. So now if this is my angle theta, this part is going to be my hypotenuse, this down part is going to be my adjacent, and this side is going to be my opposite. So now I'm going to start with sine. Sine here is opposite over hypotenuse, and if we are using this angle as a reference point, it means that my opposite is going to be here, and this is 1 centimeter, and my hypotenuse is here, which is root 2. So it means that sine theta for a 45 degrees angle is 1 over root 2. You can choose to rationalize this, and if I rationalize it, I'm going to be getting 1 over root 2 multiplied by root 2 over root 2. And I'm going to be getting root 2 over root 2 times 2, which is 4. And root 4 is 2, so this is going to be equal to root 2 over 2. So sine theta is equal to root 2 over 2 when theta is equal to 45 degrees. Now I'm going to be moving over to the next one, which is our cos. So if I'm to find cos theta when theta is 45 degrees, I'm going to be having that cos is adjacent over hypotenuse, and my adjacent here is 1 centimeter, and my hypotenuse is what? Root 2. If I again rationalize, I'm going to be getting 1 over root 2 multiplied by root 2 over root 2. So I'm getting root 2 all over root 4, which is equal to root 2 over 2. So this here is what I'll be getting when I want to find cos theta, and theta is equal to 45 degrees. Now the last one, which is tan. Tan is opposite over adjacent, and if this is the angle that we are considering, my opposite is 1, my adjacent is also 1, and 1 divided by 1 is equal to 1, so my tan theta is equal to 1. So these are the values for the trigonometric ratios of special angle 45 degrees. If you found this helpful, or if this is your first time coming across my video, please make sure to like and subscribe. Thank you.